Okay, so for the second example, we're going to be determining the percent by mass of a certain element. So I'll start by reading this. The molecular formula for the mineral schezermite is NH4Al SO4 2 times 12 H2Os. Determine the percent oxygen by mass in this compound. Okay, so by looking at this equation, the only thing that is particularly difficult is going to be this hydrate group attached to this compound, or these 12 hydrate groups attached to this compound. So to find the percent mass of an element in a compound, we're going to use this formula. So it's going to be the percent mass of an element is equal to n, and n is representative of how many elements, how much of the element is in the compound. So I'll show you in a second, times the atomic mass of the element divided by the molecular mass of the compound. And then we're going to times that by 100 to allow it to be in percentage wise. So we're looking for the percent mass of oxygen in this particular compound. So we've got a lot of numbers going on. So these are supposed to be subscripts. So let me just rewrite this. So NH4Al SO4 2 times 12 H2Os. So we're trying to find the percent mass. So how many oxygens do we have in this equation overall? So we've got 4 oxygens here times 2. So we've got 8 oxygens here. And then let's see, we have another 12 oxygens. So overall we have 20 oxygens. So we've got 20 oxygens. And we're going to multiply that by the atomic mass of oxygen. I've got my little periodic table, which is 16.00, and divide it by the molecular mass of the formula times 100. So let's figure out the molecular mass, because this can be a little tricky, especially with all the numbers, but no worries. So the atomic mass of nitrogen is 14.01. So we're going to add that to 4 hydrogen. So 4 times 1.008 plus 1 aluminum, which is 26.98. And then we're going to times that by 2, or add, and then times 2 sulfur, so 32.06, times, or plus 8 oxygens, which is 16.00. And then we can compute this and then compute it and add together. It doesn't matter. So I'm just going to go ahead and add the sulfate group along with this. So we're going to add what looks like 24 hydrogens. So 24 times some more hydrogens. We've already got 4, so actually we have 28 altogether, but it will all work out. 1.008, which is the atomic mass of hydrogen, and then plus 12, we got some more oxygens, 12 times 16.00. So that's how you compute the molecular mass of this formula. Got to include that hydrate group. So overall, that's going to be about 553.334 grams. That's how much that this compound weighs. So we'll put this back into our equation. So we'll put 453.334 grams back into our equation. So this is going to end up coming out to be 70.588%. And we'll just go ahead and put that to 4 significant figures. There's no significant figures labeled in the equation or given for a standard, so we'll just go ahead and put 4. So we have 70.59% oxygen in this compound. All right, thank you. I hope this made percent composition problems a little bit easier.